Good morning, everyone. Today we're going to look at parabolas again, but today we're going to look at them in a different light. Not just as a quadratic function, but we're going to think of them in this unit as both a quadratic function and a parabola that can open up left or right. And then that way when it does that, it is no longer a function. Today we're going to stick with the parabolas that still open up and down, and then tomorrow we'll add in those that open left and right. Okay, so this is the form we're used to. Y equals a times x minus h squared plus k. This is vertex form, and we know how to graph a parabola this way. So let's say we had y equals 2 times x minus 1 squared minus 3. So if we were to graph this, oops, we're on dotted. Let me fix that real quick. And I will change that to solid. There we go. And yeah. Okay, so if we were to graph this, we would start with our vertex. And remember, our vertex is the opposite, stays the same. So we would have a vertex at a point 1, negative 3. So we would go over 1 and down 3. Now because of the 2, our moves are doubled. So we'd go over 1 up 2 instead of 1. Over 2 instead of up 4, we would go up 8. So that's 3, 4, 5, 6, 7, 8. And then we would have a nice sketch. Whoop! Hope yours looks better than mine. I don't do so well on the Mobi with those. Okay, so we would have a nice graph of our parabola, and we could state all the characteristics. We could talk about domain, we could talk about range. So domain is from negative infinity to positive infinity. Range is from negative 3 to infinity. We could give the equation for the axis of symmetry. The equation for the axis of symmetry, it is a vertical line, so it's going to be x equals, and the x value at the vertex is 1. We also know several other things about this. So if you'll take out your notes page, and let's all look at that together. We already know a lot about a parabola. Whoops. So you can add in this form on your notes page. That is not your bell. Please ignore that bell. So you know this form, y equals a times x minus h squared plus k. And we know that the vertex is the point hk. But then we have some other words on here that we don't know. Focus, directrix. What are these things? What is the focus? What is the directrix? So let's think about what the actual definition of a parabola is. So we're not thinking about quadratic function, we're thinking about a parabola. A parabola is the set of all coplanar, that just means they're in the same plane, points whose distance from a fixed point called the focus is equal to the distance from a fixed line called the directrix. So we have this fixed line, and it is called the directrix. And this fixed point here is called the focus. And if we notice, these two are the equal distance. This distance is called P. This distance is called P. The distance from the vertex to the focus is equivalent to the distance from the vertex to the directrix. And I think I got these wrong. 1 over 4a, or P, is the distance. Got those flip-flopped. 1 over 4a, or P, is the distance from the vertex to the focus or the directrix. Now, if we look at this, the distance from the focus to the directrix is this P and another P. So that is 2P. So the distance is 2P here, 2P. So if we went out 2P this way, it's equivalent to 2P that way. And that is a new way to graph our parabolas. And we'll take a look at that one in just a moment. Okay, let me show you a quick video, and I'm going to open this up, that shows us exactly how this is formed by definition. tracing the parabola. Well, if my internet is not going to work for me this morning, I won't be able to show it to you today. I'll have to pull this up to show to you tomorrow, and it appears it is not going to work for me today. Look at this tomorrow so that you can see exactly how it's formed, and maybe that'll help us tomorrow when we also look at the parabolas that open up a different direction. Okay, so back to the focus and directrix. Since this is part of our definition, the focus, if we notice it is P units up above here, well, whatever the vertex is, we would have to add P in a vertical direction. So our focus would be the point H, comma, K plus P. That's where the focus would be. And the directrix is this horizontal line here. And the equation for a horizontal line always begins y equals, and if we look at this y value is K, but we're going P units in that direction, so it's going to be K minus P. All right, now I understand that a lot of this does not make sense until we look at it in context. So let's go back and look at the same problem in context. Y equals 2 times x minus 1 squared minus 3. Okay, if you noticed on the other one, this term here, our A, is equal to 1 over P. So if A is 2, what would P have to be? Well, some of you can look at it and just tell me, but others of us are going to have to solve for it. So if we solve for it, we would get 8P, if we multiplied by 4P, equals 1, so P equals 1/8. So let's see, I'm going to graph this in green right on top of the other. So there's my vertex. My vertex is still the point 1, -3. All right, and if we noticed, if we go up P, we would go over 2P in either direction. Do you see that? Up P, we would go over 2P in either direction to get a point on our parabola. If we went up 1/8, we would go over 1/4 in each direction. Now this one, isn't it easy to do? But I'm going to give you some examples in just a minute that help you to see this a lot more clearly. All right, and then we would go down 1/8 P to draw in our directrix. So real close, but about right there. All right, let's look at another one in context. Okay, this time I'm going to give you the equation y equals 1/8 x plus 2 squared plus 1. And we're going to graph this one using our new form. And I want everybody to do that. Nobody can be stubborn and only do it the other way, because we're going to learn different ways this. All right, so our vertex we find the very same way. It's going to be the point -2, 1. And we'll plot that point, -2, 1. Now we're going to graph this by definition of a parabola. So we're going to determine where the focus would be, where the directrix would be, and we're going to graph it by what we know about the focus and directrix. Now, remember the A, when we have it, x minus h squared plus k. When it's in vertex form, this A is equal to 1 over 4P. So in this problem, my A is 1/8. I set that equal to 1 over 4P. A lot of you guys already see it. What does P have to be? P has to be 2. So if I go up 2, I get my focus. There's my focus. If I go down 2, I now have the directrix down to. My directrix would be, and let me change this to a dash line. Now I need the dash line. So now we see the focus and the directrix. Now, remember I said you can do 2p in either direction. So if we go over 2p, well, p is 2. 2 times 2 is 1, 2, 3, 4. This distance is 2p. I'd go on either direction, 1, 2, 3, 4. And then I can sketch in my parabola. Okay, once again, I hope yours looks a little better than mine. I did not do a good job making it pretty. Now, is this any different than the other one? Let's look at the other way. The other way would say, if I had a move of 1, 2, 3, 4, 4 squared is 16, but 1/8 of 16 is 2. Is that point in the same place? Sure it is. It's the exact same equation. And we can graph it either way. But right now, I want you to look at this new method and see what you can do with that. Okay, here's a you try, and I'm going to ask that you pause the video because I'm going to keep going. Go ahead and pause the video until the class is ready to check their answer. Okay, here's the equation. Y equals 1/2 x plus 2 squared. You try graphing this parabola the new way. Press pause now. Okay, now let's take a look at what we should have here. So if we sketch this one has a vertex at the point -2, 0. So we're going to plot that right here, -2, 0. If we look at for our p, we get 1/2 equals 1 over 4p. So what does p have to be? So if you can't tell, cross multiply, p is 1/2. So if I go up 1/2, I have my focus. If I go down 1/2, I have my directrix. And you know what? I think I left off my equation for the directrix on the last one. I'll go back and add that. 2p is the distance that I move left and right from the focus to graph my point. Well, p is 1/2, so 2 times that is 1, so I'd go over 1 in either direction and sketch in my parabola. Okay, so the focus is the point up 1/2, so it's going to be -2, 1/2. And the directrix is the equation y equals -1/2. So back up here, the focus was the point, -2, 3, and the directrix is the equation y equals -1. Okay, let's do one more of these together, and then we'll move on to the next part of the lesson. Okay, let's say we had the equation y equals -1/16 x minus 3 squared minus 1. All right, so if we look at this one and we go to graph it, where would the vertex be? Well, we can probably tell from looking at this that the vertex is the point 3, -1. So the vertex is the point 3, -1. Now this one's going to open which way? It's going to open down because of the negative. So if we set this -1/16 equal to 1 over 4p, you ought to be able to tell that p is -4, which tells me my focus is -4 units down. So my focus is the point 3, -5, which means my directrix would be 4 units the other way, 4 units up. So it'll be y equals +3. Whoops, change color and make it dashed. All right. Now, if we look at this, if we do 2p, we're going to go 8 units in either direction. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. and then I have a nice fat, wide parabola. Okay, so that should give us a lot of good practice with the parabola. Now, let's say we started with a graph instead of the equation. How could we come up with the equation? All right, so if we started with a graph, and it looks something like this, what would that tell us about the equation? Whoops, I just put that in the wrong place. Hold on, I'm moving it. There we go. Okay, so here's our graph. What's the equation? Well, we need a couple things. We need to look at the vertex. The vertex is the point, -3, -2. The focus is 2 units up from that, -3, 0. Even if that's all they gave us, we could come up with the equation for this graph. Because we know where the vertex is, because the focus is always inside the parabola, we know it's opening up, and we can tell P. There's 2 units difference between here, so we know that P is 2. So we can write the equation. We're thinking 1/4P, because that's what A is equal to, times x minus h squared plus k. So we're going to put in our P. 2 times 4 will give us an 8 here. We're going to put in our -3, which makes that positive, and our -2, and we have the equation. So all we need is to be able to figure out where the vertex is, find that P, and know whether it's opening up or opening down. We could also do this if they just gave us a directrix. Let's say the directrix was, let me make that look like a capital D, or else it looks like a B. The directrix is the equation, y = 4. And the focus is at the point let's not do -3 again. I just did -3. Let's do 2, -6. Well, in every one of these, if this is P and this is P, and we look back, this is P and this is P, and we look back, whoops, this is P and this is P, this is P and this is P. We know that the vertex is always P units from both of them, which puts the vertex right in the middle, doesn't it? So if we look at this, we want a vertex that's halfway in between the point 2, -6, and the line y = 4. So the vertex would be halfway. So it's going to be 2, and what's halfway in between these two? -1. So now we know the vertex. How can we figure out which way it's opening? If we look at this, the directrix is above the focus. Well, if the directrix is above the focus, let's look back. When the directrix is above the focus, we know it must open down. So now we know it's going to be y = x minus 2 squared minus 1. Now, how can we figure out what goes here? Well, this is 1/4P. And P is that halfway point. It is a distance of 5 units. So 4 times 5 is what goes here. So the equation for this would be y = -1/20 x minus 2 squared minus 1. And the last form I want to talk about is that other form we see on here. Do you see if I take this equation right here, and substitute the 1/4P in here, and move the K over, and then I multiply it by the 4P. I get 4p times y minus k equals x minus h squared. So here is another form that we can write our equation in. So you can see this sometimes. And how would that look for us? So let's say we had 16 y minus 2 equals x plus 1 squared. So when it's in this form, if we look at it, this was y minus k, x minus h, and 4p. So we can see our p is, well, what can I multiply times 4 to get 16? 4. And our vertex is always hk. That's always our vertex. Whoops. So if we look at this, we're going to go opposite, opposite this time. So it's -1, +2. So that's just one other form we might see. All right, I'd like you to start the homework problems that are written on the board. I'll be back tomorrow to answer any questions about parabolas that open up and down when we're using the parabola form, the conic form. And then we will start the ones that open left and right tomorrow. See you then.